Right, now I mentioned before that the craft uses what's called a plasma accelerator. And this is what I think it would look like if we were to look inside it. So we're looking at it, let's say if we go over the prototype one, which was 200 feet along each side, you're looking at a 100 feet diameter tube, which is about 10 feet across. So you could probably walk around this structure inside there when it's powered down. In there, they fill it with a mercury-based plasma, which is a gas which has become ionized. Pressurize it to 150,000 atmospheres, which is extremely high pressure, or in the operational models, 250,000 atmospheres, and it's then spun around in a circle at 40,000 revolutions per minute, so 40,000 RPM. Right? So what you've got in a plasma, you've got charged particles, and you've got them going around very, very, very fast in a circle. Now, a charged particle which moves creates a magnetic field. If you have charge flowing in that direction, you get a magnetic field at 90 degrees to it in that direction. So what you're going to get a magnetic field enveloping the whole craft of some phenomenal strength, which I'm going to come on to. Ed describes it as a magnetic vortex field. Now, the thing that enabled them to develop these plasma accelerators, allegedly, is the material that the device was made from, the thing that's withstanding this massive pressure. And he describes it as a foil-like material as thin as a plastic bag, which you can't cut with a knife. And they used 12 layers of it in this plasma accelerator. And this is what he talks about in this next clip.
Another friend who worked for General Dynamics in Fort Worth described a program in which he worked a plasma accelerator in the mid-60s, researching gravity warping techniques. He is a physicist by education and trade. This was his first top secret program. He described a foil-like material, much like that discovered after Roswell crash. He described the foil as 12 layers of material less than 10,000ths of an inch thick. It was as flexible as a plastic trash bag, but virtually indestructible to piercing, burning, or cutting, which you've probably all heard before. Here's what you haven't heard. In order to cut the material used for the project, the material was supercooled, a large electrical charge was applied to polarize the molecular structure, and a laser cutter was applied in order to cut this material. Large ribbons of this material were used to reinforce the accelerator, which contained the mercury-based plasma that they started researching in 1965. The plasma was cooled to superconductive temperatures, rotated at 45,000 revolutions per minute, and pressurized at 150,000 atmospheres. This would be considered state-of-the-art technology even today.
All right. Now, in the next clip, he describes some of the characteristics of the craft, because they've made this plasma accelerator, they've got it to actually reduce its own weight. This magnetic vortex field is affecting the gravitational field around it, and is also presumably reducing inertial forces if the thing changes direction. So it's reducing its own mass. This is physics which is not in the white world. Anyway, he describes the characteristics in this next clip.
Was 200 feet across, the prototype. The tactical reconnaissance TR-3B first flight was in the early 90s. The triangular-shaped, nuclear-powered aerospace platform was developed under the top-secret Aurora program. By 1994, there were $3 billion-plus operational models. The operational model is 600 feet across. This flying triangle is not fiction. If you don't believe me, ask the tens of thousands of people who have now spotted one version or another of it, from Belgium to England. Ken can tell you about people that have seen it in England to Arizona. The TR-3B vehicle's outer coating is reactive to electrical radar stimulation and can change reflectiveness, radar absorptiveness, and color. The circular plasma field accelerator ring, called the magnetic field disruptor, surrounds a rotatable crew compartment. It's far ahead of anything you've ever imagined as far as technology. Sandia and Livermore Laboratories developed a reverse-engineered MFD, and I believe the government will go to any lengths to protect this technology. The plasma in this accelerator is mercury-based. It's pressurized at 250,000 atmospheres at a temperature of 150 degrees Kelvin, superconductivity, and accelerated to 60,000 revolutions per minute to create a superconductive plasma with the resulting gravity energy. The MFD generates a magnetic vortex field which disrupts and neutralize the effects of gravity on mass within proximity by 89%. This causes the effect of making the aircraft extremely light and able to outperform any aircraft yet constructed. TR-3B is a high-altitude stealth reconnaissance platform with indefinite loiter time. Once you get it up there at speed, it doesn't take much propulsion to maintain altitude. With the vehicle's mass reduced by 89%, the vehicle can travel at Mach 9 vertically or horizontally. So for those that have had sightings of things making right, and they're not perfect right turns, obviously. Nothing can make a perfect right turn. It's against the laws of physics. But it sure looks like a right turn at a distance.
So what he's saying is that the field generated by this plasma accelerator reduces the weight of the whole thing by 89%. So let's say you weigh 10 stone. If you stood in the middle, you weigh 1 stone. All right? And the whole craft's weight is reduced. Now, let's ask the question, does this seem plausible? Is there anything in our physics textbooks that we can verify this with and say, well, is he telling us the truth? Well, here's a science paper from 2010 entitled Generating a Magnetic Field by a Rotating Plasma, 12 years after Fouche's initial disclosures. So, yes, it is possible to generate a magnetic field by rotating a plasma. But is it possible to use a magnetic field for propulsion? The Lorentz force is the magnetic force in physics. So in electric motors, you have two components which you pass electricity through. Each produces a magnetic field, and it's the force between those fields that turns your electric motor, your lawnmower, your washing machine, what have you. But can you use that force to make something float off the ground? It's not that easy because the Lorentz force requires two components, one which pushes the other apart. So if you try to use it for propulsion, the component which is being pushed upwards will leave the thing that's pushing it. So it's a bit like trying to lift yourself up off a chair and float in midair. You can't do it. But according to Fouche, if you get the magnetic field strong enough and in this configuration of a magnetic vortex field, I would imagine it's something the shape of, because every magnetic field has a shape, it has topology, right? So the shape would be something like water going down a plug hole. And I suspect it requires a field which is of immense strength before it starts to affect gravity. And I'm going to come on to that now. Let's just ask the question, if we were able to rotate a plasma at 40,000 RPM, as Ed Fouche claims, what would the strength of the magnetic field? Now we can ask that question by comparing it to electricity in a wire. When you pass electricity down a wire, you get a magnetic field at 90 degrees to it, going around that wire. The further away from the wire, the weaker the field. All right? Now you can put your wire in a circle and allow your electrons to flow around in a circle, very similar to the TR-3B. So you've got charged particles going around in a circle, just like the plasma accelerator. And it produces a magnetic field this shape, all the way around the ring. So it's something like that that the TR-3 is going to be generating. So B here is the magnetic field strength measured in Tesla. The equation for magnetic field strength for a charged particle flowing in a direction is given by this equation here. Mu naught over 4 pi times QV over R squared. Don't get frightened by that. It's not as complicated as you might think. Mu naught over 4 pi is a constant. Okay, so we can pretty much forget about that term. R is the distance from the charged particle to where you're measuring the field, right? So all this term means is the further away you get, the smaller the field. So we can forget that term. The two important terms is V, that's the velocity of your charge, the speed of your electrons, and Q, the number of electrons, how much charge is there. So in a copper wire with DC current flowing down it, electrons flow at 0.735 millimeters per second. Electrons will flow at 0.7 of a millimeter in 1 second. That's how fast electrons go down the wire, right? Now let's compare that speed, V, with a plasma in Fouche's accelerator. He said it was 100 feet in diameter, and he said it was going around at 40,000 RPM. That comes out at a speed of 64,000 meters per second. compared to 0.0000735 meters per second. So the plasma, or the charged particles in the plasma accelerator, are travelling 87 million times faster than the electrons in a copper wire. So if the other factors in this equation were the same, it means that B, the magnetic field strength, is going to be 87 million times that of the field produced by a wire. Now let's look at the other term. So do we have the same amount of charge in a plasma though? Well, the charge in copper, or the electron density, is 8.4 times 10 to the 22 electrons in every cubic centimetre of copper. How does that compare with a plasma? Well, the electron density in a plasma depends on the type of plasma, and it depends on the temperature. But looking at this graph, if we just look at the electron density of 10 to the 22 here, right, we see that metals, or metal plasmas, exist at about, in other words, supercooled. Fouche said that the plasma accelerator was cooled to 150 degrees Kelvin. That's about minus 120 odd centigrade. So this is all making sense to me. The electron density of metals, because this was a metal-based plasma, it's a mercury-based plasma, supercooled, would produce a similar electron density to that of copper. So that's why they've probably got to supercool it, so that the plasma can obtain that particular electron density. So from those figures, I would suggest that the magnetic field strength using this plasma would be thousands of times higher than using wire and copper. Sorry, using wire and electricity. Now, this table here shows typical magnetic field strengths, fixed magnetic field strengths, because you can't have pulsed magnetic fields, but I think we're talking about fixed magnetic fields. If you've got something going around in a circle at a fixed speed, the field is going to be fixed. It's not going to be pulsed. So a typical magnetic field in a power transformer is between 1 and 2 Tesla. Tesla is the unit of magnetic field strength. I particularly like this one. Where is it? Strength. Yeah, 16 Tesla is the magnetic field strength used to levitate a frog. Right, but the strongest magnetic field ever produced in a laboratory, this is a fixed magnetic field, not a pulsed one, ever produced in a laboratory, is 45 Tesla. And that's it. So I think they're producing fields with the TR3B of thousands of Tesla. So there's no physicist can stand here and say to me, well, if you get a magnetic vortex field of, say, 10,000 Tesla, it will not affect gravity. They can't say that because they've never produced one in a laboratory. And the reason why they've never produced one in a laboratory is because they haven't got the materials that they used in that TR3B plasma accelerator. So has Ed Fouche taken all of this into account when he's made up his story? I don't think so. Now, they have produced pulsed magnetic fields in the order of thousands of Tesla, a few thousand Tesla, but they've blown the laboratory up. Because with a pulsed magnetic field, you get voltages induced, and they just blow everything up. But a fixed magnetic field, I think, is what we're talking about. So this is all adding up to me. And just to reiterate, no scientist can say to you that if you had a fixed magnetic vortex field of, let's say, 10,000 Tesla, that it wouldn't suddenly interrupt gravity, because they've never done it in a lab. Okay? Now, Ed said that these craft were capable of Mach 9, that's 6,900 miles per hour, not just horizontally but vertically. At that speed, from a standing start, you'd be in space in 40 seconds. A 600 feet triangle in space, in orbit in 40 seconds. And we were all shown the space shuttle on TV. 10, 9, 8, 7. It is a big, big con. Now, if we imagine that they've increased this capability, because we're talking about 1990 here, these capabilities. Let's say they've increased the capability by tenfold. You're talking 70,000 miles per hour, right? That would take you under 4 hours to get to the moon, and it would take you just 3 weeks to get to Mars. Now, if you've got a 600 feet platform that you can get to the moon in a few hours. You can put it on the surface of the moon, use it as a base, take it to Mars, take it to any planet in the solar system. Do you think that they're not going to do that? Or do you think they're just going to put it in a cupboard and let it gather dust? I think they've been there and they've got the T-shirt. One person who made claims about this in 1998 was a guy called William Hamilton.
This colonel is a real warrior type guy, and he had a degree in plasma physics. And he was also a consultant to NASA, and he was a consultant to people out at the Palos Verdes nuclear power generating station just 50 miles west of Phoenix. The other thing he said was there was a base on the moon. I find that quite astounding. I mean, I have heard astounding things, not only from this colonel, okay, but also probably the highest rank was a retired 3-star general, lieutenant general in the Air Force. And he knew another guy that I was in contact with, and this other guy claims that he worked 7 years on the U.S. anti-gravity program. I have a fraction of what he told me, and I've got it tape recorded. It's true. Whoa. What a sham the space program is. Because there's another space program going on. A secret space program. And that's what I was attempting to find. In fact, you don't have to go too far to find that there is some secret space programs going on, because they had their own shuttles and their own astronaut crews right out here at Vandenberg Air Force Base, unbeknownst to everybody, and they scuttled a $5 billion facility that was housed there at one time. That was back in the 80s. But the kind of space program he was talking about is using a spacecraft that can leave the bounds of our atmosphere and travel to the planet Mars at 0.8 C. 0.8 the speed of light. And I said, how do you know that? I've been there, he said.
All right, now we might ask the question, well, what the hell is NASA all about if this stuff is going on? What are NASA doing? Well, I'm going to show you a clip of Barack Obama speaking at the Kennedy Space Center in 2010. And Obama is laying out NASA's program of work for the next 5, 10, 15, 20 years. And I just want you to consider technology for a moment, your communications technology, your mobile phone, and compare it to the 1960s and 1950s and how much it has advanced. It's incredible, isn't it, what we have now in communications technology. But compare that to propulsion. We had rockets that we could control and get into space in the 1940s. 1940s. NASA is still using rockets now. It seems that there's been no advancement in their technology with regards to propulsion. And I think it's because NASA is a cover organization which is just presenting technology to keep the public passive as to space and to not question about what's going on that the N.S.A. and the Air Force are developing, because they're running the real space program, not NASA. And what I've done with this clip of Barack Obama is I've put on the screen here what I think is really going on. So listen to Obama's words. You might need to stand up at the back to see them, but if you read the bottom of the screen, this is what I think the real picture is, and Obama is just part of one massive cover-up.
We're no longer racing against an adversary. We're no longer competing to achieve a singular goal like reaching the moon. In fact, what was once a global competition has long since become a global collaboration. By doing that, we will ramp up robotic exploration of the solar system, including a probe of the sun's atmosphere, new scouting missions to Mars and other destinations, and an advanced telescope to follow Hubble, allowing us to peer deeper into the universe than ever before. We will increase Earth-based observation to improve our understanding of our climate and our world. And we will extend the life of the International Space Station, likely by more than 5 years, while actually using it for its intended purpose. And in order to reach the space station, we will work with a growing array of private companies competing to make getting to space easier and more affordable. we will build on the good work already done on the Orion crew capsule. I've directed Charlie Bolden to immediately begin developing a rescue vehicle using this technology, and this Orion effort will be part of the technological foundation for advanced spacecraft to be used in future deep space missions. In fact, Orion will be readied for flight right here in this room. We will invest more than $3 billion to conduct research on an advanced heavy lift rocket, a vehicle to efficiently send into orbit the crew capsules, propulsion systems, and large quantities of supplies needed to reach deep space. In developing this new vehicle, we will not only look at revising or modifying older models, we want to look at new designs, new materials, new technologies that will transform not just where we can go, but what we can do when we get there. And we will finalize a rocket design no later than 2015 and then begin to build it. And by 2025, we expect new spacecraft designed for long journeys to allow us to begin the first ever crewed missions beyond the moon into deep space. We'll start by sending astronauts to an asteroid for the first time in history. By the mid-2030s, I believe we can send humans to orbit Mars and return them safely to Earth. And a landing on Mars will follow, and I expect to be around to see it. Critical to deep space exploration will be the development of breakthrough propulsion systems and other advanced technologies. So I'm challenging NASA to break through these barriers. And we'll give you the resources to break through these barriers. And I know you will, with ingenuity and intensity, because that's what you've always done.
Yeah. He's just a slightly more sophisticated version of Ed Miliband, being used to cover things up.